Okay, so at the top up there, there's a reminder of what we did in chapter 1. It says that a to the second power, which is a squared, that means a times a, right? I'm talking about this right here. All right, and then if you have a to the third power, or a cubed, that means a times itself 3 times. So that's a times a times a. Now, does anybody happen to remember what a to the 0 power is?
1.
What was that?
1.
Yes, it is 1. Any number to the 0 power is 1. So that's what I want you guys to draw or write in right here. So any number to the 0 power is 1. So for example, if I gave you 13 to the 0 power, you would say it is 1. Okay? Now negative exponents, those have nothing to do with the answer being positive or negative. That's just a notational thing. So if you have something like a to the negative n power, that's just 1 over a to the positive n power. So all that negative exponent tells you to do is move that thing, move the base. So if it's in the numerator with a negative power, you move it to the denominator and you change the power from negative to positive. So for example, if I gave you one like 2 to the negative 3 power, well, right now that's in the numerator. We're going to move it to the denominator, so we're going to put 1 over. And it's going to be 2 to the positive 3 power. So again, if it's a negative exponent, all it's telling you to do is move it. And then what's 2 to the third power? That's 2 times 2 times 2. That is 8. It's not 2 times 3. It's not 6. It's 2 times 2 times 2 is 8. All right? So we should be able to fill in the rest of that chart at the top now. So 5 squared, what's 5 to the second power? What's that? Yeah. What is it? 25. It's 5 times 5 is 25. 5 to the first power, well, that's just 5. What about 5 to the 0 power? 1. Shh. Any number to the 0 power is 1. Then it says 5 to the negative 1 power. That's going to be 1 over 5 to the first, right? Which is just 1. That's just 1/5. And then 5 to the negative 2 power? Yep. That's going to be 1 over 5 to the second power. For the rule that we just learned, right? So that is 1 over 25. All right, so let's do these examples. Again, this should go pretty quick. Let me zoom in a little bit so you can see them better. All right, so we got 2 to the negative 4 power. So where do I put the 2? What do I have to do when it has a negative power? You have to move it, all right? Anytime you see a negative power, you like to move it. All right? So we're going to change that. We're going to write the 2 in the denominator, and we're going to change the power from negative to positive. So again, it's a notational thing. It's not whether the answer is positive or negative. You just have to move it. So that's 1 over, what's 2 to the 4th power? Yes. Again, it's not 2 times 4. It's not 8. It's 2 times 2 times 2 times 2 is 16. So that one is 1 over 16. Same thing on the next one. Somebody want to tell me what to write? Sid?
1 over 4 to the third.
Excellent. And then we need 4 times 4 times 4. Yep, 1 over 64. Good. All right. And number 3 there? Yeah, that one's just 1. Any number to the 0 power is 1. Number 4. Look at the difference between 4 and 5 there. You see on 4 how the negative 5 is in parentheses? Well, let me pause this so I can take care of what's going on over there. Matt, do not throw stuff in my room. All right? And Damien, you don't have a right to fly that bird in my classroom. All right? That will send you down to ISS. You got it, Matt?
Yeah.
Thank you.
Oh,
Quiet, please. I am recording this. So again, the difference between 4 and 5 is in 4, the negative 5 is in parentheses. That means that whole thing has to go in the denominator. All right? So you're going to move that whole thing. So you're going to put a negative 5. Oh, sorry, not a negative 5. Yeah, negative 5, that's right. A negative 5 in parentheses. And you're going to just change the power from negative to positive. So you guys see that I just moved it? I just moved that negative 5 from the numerator to the denominator and changed the power from negative to positive. And then, now if you got a negative number to an even power, is that going to be positive or negative? Yeah. Yeah, because if you have negative 5 times negative 5 times negative 5 times negative 5, anytime you have an even number of these, well, if I do a negative times a negative, that's a positive, right? Same thing here. If I got another pair of negatives multiplied, that's going to be positive. So the answer is going to come out positive. It's going to be 1 over, but then we got to know what 5 to the 4th power is.
625.
625.
So we get 1 over 625. Now, if you want to use the calculator to help you, you can. But you got to make sure if you're using those graphing calculators in here, if you have a negative number raised to a power, you need to put these parentheses in there, all right? Otherwise, you will get the wrong answer. All right, the next one. It looks pretty similar to the other one, doesn't it? But there's a difference here. That negative 5, I want you to think of that negative 5 as really like negative 1 times 5. Okay? So that means that negative 4 power is only on the 5. It's not on the negative 1. Accidentally hit Siri. Okay. So then, do you guys see the difference? So that means I'm only going to move the 5. I'm not going to move the negative 1. So I'm going to keep the negative 1 where it's at, and then I'm going to put the 5 in the denominator and change the power from negative to positive. Well, that's going to give me negative 1 over 625 then, right? You guys okay with those two? All right. All right, the next two, same thing really, just you got to substitute in whatever number they give you for the variable, that's all. So number 6, we just got to plug in the 4 for the x. So that's going to be 4 to the negative 2 power. So what's that going to be the same as? So,
4 to the second.
good. Thank you, Rachel. That's 1 over 4 to the second. So that is 1 over 4 to the second power is 16. Good. All right, number 7. I didn't miss any of them, did I? No. Number 7, again, we're going to plug in the 5 for the A. So we're going to take the 5 and put it in there for A. And then we're going to take the negative 3 and plug that in for B, or substitute for B. All right, so when I do that, that's going to look like negative 2 5 to the 0 power. And again, when I put that negative number to a power, I'm going to put that negative number in parentheses. So I'm putting that negative 3 in parentheses when I substitute that for b. And then that's to the negative 4 power. All right, well, here's an important idea. That negative 2, or that 2 right there, what power is on that 2?
1.
That's a 1. So when it has a positive power, don't move it. Okay? It's only when it has a negative exponent that you move it. So then we're going to get negative 2. Well, then times 5 to the 0 power. Well, what's 5 to the 0? Yeah, any number to the 0 power is 1. So that's a 1. And then times. And then where does that negative 3 go? Where? Down? Yeah, it goes down in the denominator. So that negative 3, that whole thing goes in the denominator. And we change the power from negative to positive. So the numerator is just negative 2 times 1. That's negative 2. The denominator is going to be negative 3 to the 4th. So is that going to come out positive or negative? Yeah, that's going to be a positive. You don't need to write that, but it is positive. And then we got 3 times 3 times 3 times 3. That is 81. So you don't need that positive sign there. I just put it there for a second. All right, and then the last couple examples here. We got, what, 3 more to go? These are, it's the same thing. But now the base, instead of being a number, it's going to be a variable, but it works the same way. So what power's on the 7 there? What's that? That's a 1. So do we move that one? Yes or no? No. If it's got a positive power, don't move it. Leave it where it's at. So the 7 stays in the numerator, and the W goes into the denominator, and we change the power from negative to positive. And that's it for that one. Let's try number 9. What power's on that 5? A 1, so it's going to stay in the numerator. Now, I've been saying all along that if it's in the numerator and it has a negative power, you move it into the denominator and change the power from negative to positive. Well, this one has the negative power in the denominator. So where do you think you're going to move it?
The numerator?
Yeah, you're going to move it into the numerator and change the power from negative to positive. That make sense? So if the exponent's negative and it's in the denominator, you move it to the numerator, change the power from negative to positive. So whenever you move it, you change the sign on the exponent. So the negative 5 stays where it's at. That's in the numerator. And then the k also comes up in the numerator. And you change the power from negative to positive. Now that would be over 1, but you don't need that. So it's just negative 5k squared. And then last one. I'll leave that there for a second. I guess you guys can see that for a second. So we're going to do the last one. So number 10. So number 10, let's see, what should we do? Well, first of all, what's a to the 0 power?
1.
That's 1. So the numerator is just 1 times b to the negative 2. And then c to the negative 3 times d to the 6th. Now, which one are you not going to move?
The d to the 6th.
Good. If it has a positive power, leave it where it's at. So the d to the 6th is going to stay down there. Now, what do I have to move? The b and the c. So where does the b go? Where? In the bottom, yep. So the b goes down into the denominator, and I change the power from negative to positive, 2. And then where does the c go? Yep, the c goes into the numerator on top, and I change that power from negative to positive. So then, I guess I can't do that from here. So that's it for 7-1. So you can see that's a lot. I'm not going to say I guess it's a little easier, but definitely shorter, right? Problems are shorter than they were in chapter 6. So let me stop this recording.